Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. Before starting today's session, we'll just revise what we learned in the previous session. In the previous session, we started a study of reference electrodes. As you know, a galvanic cell is prepared by connecting two electrodes. One is anode and another is cathode. And a cell potential can be measured by adding the potentials of taking place at anode and cathode. That is, in a galvanic cell, simultaneously reduction and oxidation takes place and total cell reaction is a redox reaction. We learned all about this. Now, what would happen if potential of one of the electrodes in a galvanic cell is known? Then we can easily calculate potential of another electrode because total cell potential can be easily measured, and as total cell potential is algebraic sum of two electrode potentials, and if we know the potential of one of the electrode and total cell potential is measured, then the potential of another electrode can be easily calculated. So reference electrodes are those electrodes whose potential is arbitrarily taken as zero or is exactly known. That means the EMF is assigned exactly to zero or it is known. Then by calculation we can find out the potential of single electrode. So reference electrodes are very important to calculate potential of single electrode because they can be used as anode or cathode by connecting to another single electrode. And in this concept, we have started studying about standard hydrogen electrode. In the previous session, we learned about the construction of standard hydrogen electrode, and today the remaining part, that is electrode reactions and applications as well as the difficulties, all we are going to learn about SHE today. Now, we will just revise the construction of standard hydrogen electrode. The figure, we have seen it, standard hydrogen electrode. Just by looking at the figure, we can revise or we can write easily the construction of the cell. The main part of this construction is platinized platinum plate. That means a platinum plate coated with platinum black to adsorb hydrogen gas. As hydrogen is in gaseous state, so the metal strip we can't prepare here because hydrogen is in gaseous state. Otherwise, we prepare a single electrode by dipping the metal strip in the solution of its own ions. Here, we are going to dip platinum plate adsorbed with hydrogen in the solution of H plus ions. Basically, the concept is same, but for the adjustment, we are using platinum plate as hydrogen is in gaseous state at normal temperature. So, we have used a platinized platinum plate. This platinum plate is connected to a narrow glass tube by a platinum wire. In the narrow glass tube at the bottom there is mercury. That mercury is for better electrical contact. Through the mercury, a copper wire comes out through the narrow tube and which is then connected to another electrode. Now, this assembly, total assembly with the narrow glass tube and platinized platinum plate is covered from the outside by an outer glass jacket. And that glass jacket has one inlet at the upper end. This inlet is for the bubbling of pure and dry hydrogen gas at 1 atmospheric pressure. The conditions are maintained to get zero potential. This hydrogen gas, this comes through inlet and gets adsorbed over platinized platinum plate, which is dipped in the solution of H plus ions that is taken in this vessel, in which this outer glass jacket is kept. Now, understood? So, we have dipped metal in the solution of its own ions. This is construction of a standard hydrogen electrode. Here we have to maintain three conditions which are basic, because the potential of SHE is arbitrarily taken as 0. For that, the gas should be pure and dry. It should be bubbled at 1 atmospheric pressure, and the solution of H plus ions should have 1 molar concentration. We also learned about the formulation of standard hydrogen electrode. Here H plus ions, a single vertical line, they are in direct contact with hydrogen gas, but hydrogen gas is adsorbed on platinum plate. So single vertical line H2 gas at 1 atmospheric pressure with single vertical line PT. All of them are in single vertical line, shows that they are in direct contact. Understood? This much we have learned in the previous session. Now, in today's session, we are going to start with electrode reactions. As you know, this SHE or hydrogen electrode can be used as cathode or anode. Accordingly, the reaction can be reduction reaction or oxidation reaction. So, here in the formulation, we have written as if hydrogen electrode is used as cathode. Hence, as you know, at cathode there is always reduction. So, we will write the reduction half reaction at the electrode. If same electrode SHE can be used as anode, if it is used as anode, then the reaction can be reversed and it can be written in the manner as if oxidation takes place there. So, it's our part that we can use it in any way that depends on with which metal or with which electrode we are going to connect the SHE. Because cathode potential or reduction potential is always higher. So that we are going to learn later. But now just remember that we are connecting or we are using SHE as cathode. Understood? So electrode reaction. Now when a reaction starts or when we start bubbling of the gas, what happens? The platinum black is capable of absorbing large quantities of hydrogen gas, and that allows the change from gaseous to ionic form and the reverse process to occur, because we are not using metal plate. Hence, the platinized platinum plate absorbs the hydrogen gas and converts that into ionic form. The reduction half reaction that occurs at electrode can be written like this. H plus electron gives H atom, but as it is hydrogen gas, hence we have taken it as 2H plus 2 electrons gives H2. As electrons are gained here, it is a reduction half reaction, and when the process completes, we get EMF of 0.0 volt. That means it is a reference electrode, because reference electrode is that which gives either zero potential or the potential is exactly known. Now, this is electrode reaction. Now, we will see the applications or uses of a standard hydrogen electrode. It is used as a primary reference electrode, very important use, to determine the standard potentials of other electrodes. That means we can connect SHE to any other electrode and that electrode of our choice. If I want to prepare a zinc electrode, then I have to use zinc metal and dip it in the solution of zinc sulfate or any zinc salt, so that it produces Zn plus 2 ions. If I want to prepare electrode of copper, then dip copper metal in copper ions and connect it to SHA, find out or measure total cell potential and find out the potential of single electrode that we have attached. So SHE is a primary reference electrode. Why it is called primary? The EMF of this electrode is zero, and when it is zero, it is called primary reference electrode. And when the EMF is known other than zero, but it is known, exactly known, then it is called secondary reference electrode. So SHE is used as primary reference electrode to determine the standard potentials of other electrodes. We will take an example how it is exactly used. Afterwards, first we will see the difficulties in setting SHE. What are the difficulties in preparing SHE? Because we should get or we must get zero potential. To get zero potential, so many conditions are kept, and those conditions are the difficulties. And the first one of which, it is very difficult to obtain pure and dry hydrogen gas. Hydrogen gas, when it is mixed with air, then it becomes impure also, and it gets some moisture added to it. So the hydrogen gas, which is to be bubble, should be pure and dry, and to get it is very difficult. Second difficulty is again the condition. The pressure of the hydrogen gas, we said that it should be 1 atmosphere, but to maintain that pressure at 1 atmosphere throughout the experiment, throughout the measurement, is very difficult. At the start, we can keep it, but to maintain the pressure to 1 atmosphere is somewhat difficult. That is second difficulty in setting SHE. And third difficulty, again, third condition is that the solution we are using should be of 1 molar concentration. The concentration of H plus ion solution cannot be exactly maintained at 1 molar, or it is very difficult to keep it 1 molar, because at the start we can take the 1 molar concentration. But because of the bubbling of gas, we are bubbling the gas into the solution, evaporation of water may take place. The temperature increases because of the bubbling, and the solution or the water gets evaporated. And when the quantity of water gets reduced or decreased, that results in changing the concentration of the solution. So to maintain all the conditions that we have mentioned, those three conditions are the three difficulties. The first is to keep pure and dry hydrogen, second is to keep 1 atmospheric pressure, and third is to keep 1 molar concentration of the solution. These are the three difficulties in setting SHE. So it is also a question that can be asked in the exam. So remember that always the conditions are the difficulties. Now, as I told you, how to determine the standard potential of by using SHE, we will see it by taking one example. To determine the standard potential of, suppose we have taken one electrode like this, Zn plus 2 Zn. That means Zn strip dipped in the solution of Zn ions. Now, suppose we have taken this electrode and we combined it with SHE to form the cell. How? So, like this, Zn plus 2 as it is written on the left side, that means it is anode. Zn is converting to Zn plus 2 by giving 2 electrons. So, oxidation takes place here. Here, hydrogen electrode, it is written on the right side. That means it is cathode. H plus with 1 molar concentration, single vertical line, H2 at 1 atmospheric pressure, and that is adsorbed on PT, that is platinum, with single vertical line. These three are to direct contact. There is double vertical line. That what it tells. So these two electrodes are connected by salt bridge, or they are connected indirectly to each other. So suppose we want to measure, or we have prepared the cell like this. Now if we measure the cell potential, then we know the potential of this side is 0. That means the potential that comes, that belongs to this. Hence, how it is measured? The figure, see like this. The figure is like this. This is SHE. We have seen the figure. It is platinized platinum plate. H plus ions, that means the solution here in that vessel is 1 molar H plus ion solution. There is one inlet for bubbling of hydrogen gas. So this is cathode. Anode is zinc dipped in the solution of 1 molar ZnSO4 solution. Zinc with Zn plus 2 ions. And this metal strip is of zinc. These two are connected by salt bridge. This is salt bridge. And these are connected internally by using salt bridge and externally by using a galvanometer. So this is the figure. Actual cell looks like this. So this is anode, this is cathode, and both are connected. Now this galvanometer gives us reading and we can measure the cell potential easily. And that total cell potential belongs to zinc only because this hydrogen has zero potential. Understood? So this is the way by which we can measure the standard potential of any electrode. Just we have to connect here that electrode we have prepared. Understood? So we will see actually as shown in figure how can we calculate the EMF of zinc electrode. So for that formula is needed. The standard cell potential E0 cell, it is measured, or the formula is like this: E0 cell equal to E0 of RHE, that is cathode, minus E0 of LHE, that is anode. Here cathode is hydrogen, anode is zinc. Hence E0 cell equal to E0H2 minus E0 Zn. But E0H2 is 0, hence E0 cell will be equal to minus E0 zinc. That means the measured EMF of the cell is equal to the standard potential of zinc electrode only and not the SH. SH is 0. Understood? So we can easily calculate EMF of the single electrode by connecting it with the reference electrode, and that is SH. Now, if the conditions are not maintained according to the standard conditions, that means pressure of 1 atmosphere, concentration of 1 molar, then what to do? That we will see. Suppose for hydrogen gas electrode like this, our irregular SHA, if concentration of H plus ions is not maintained at 1 molar and pressure of the hydrogen gas is not maintained at 1 atmosphere, that is means it differs from unity, that is 1. Then also we can calculate EMF of the cell by using Nernst equation. Do you remember Nernst equation? E cell equal to E0 cell minus 0.0592 divided by N into log to the base 10 to the concentration, product of concentration of product divided by product of concentration of reactant. That is our Nernst equation. Now for that electrode reaction is needed. So we will write first the electrode reaction for this SHE. The reaction is like this that we have seen. Twice H plus 2 electrons gives H2. So the value of small n will be 2 as 2 electrons are gained, and this is product and this is a reactant. Only one product is there and only one reactant is there. So by using Nernst equation, E cell, instead of that we will say now EMF of hydrogen SHE equal to E0H2, that is standard value, minus 0.0592 divided by N, instead of N now we will use 2, into log to the base 10 of concentration, product of concentration of products will be in the numerator. Here only one product is there, that is hydrogen gas. Hence as it is in gaseous state, its pressure should be measured. So pressure of hydrogen gas divided by concentration of H plus raised to 2, because 2 H plus ions are there. So concentration of H plus into concentration of H plus. So this is the formula. We know the values. The value of E0H2 is 0. So that is cancelled here. As for E0H2 is 0, hence the equation will become minus 0.0592 divided by 2 into log to the base 10 of pressure of hydrogen divided by concentration of H plus raised to 2. So by using Nernst equation, we can calculate the value of cell potential or the value of SHE by using Nernst equation. So up to this for today's session. Now the time for assignment. Question number 1 will be, explain electrode reactions occurring in SH. Only that one reaction I have given, that you have to write by writing the voltage also, that is 0 volt. Okay. And the question 2 will be, give applications. Only one application is there. and difficulties. 3 difficulties are there in setting up SH. So, this is for today's session. Thank you.